Hello everyone, in this video we'll look at another concept in combinatorics, and that is the concept of combinations. In the previous video we looked at permutations and we saw how permutation is counting of arrangement, however the order of the arrangement matters. In this video we'll look at combinations, and combinations is rearranging of elements regardless of the order. So as we saw it in permutations were rearranging of elements where order matters. However, in combinations, the order does not matter. So it's just rearranging of elements regardless of order. And to give you the previous example that I gave you about salads and safe codes, so my salad is a combination of cucumber, tomato, and lettuce. No matter how we put these elements together, eventually we get a salad. But if the safe code is 5682, then it has to be 5682. It cannot be 5628 or 5286. It has to be in that order. So as you can see in the second example right here, we have a permutation because the order of the elements matter. However, here we have a combination because the order of the elements does not matter. And in combinations, we count the way something can be arranged regardless of the order. So the general notation for combination is this. It's NCR, N being the total number of objects and R being the number of objects chosen. In permutation, we had NPR because permutation is P and combination is C, so here we have NCR. So we have two types of combinations. Either we have a combination where repetition is not allowed, and the rule of it is this: it's n factorial over r factorial times n minus r factorial, or where repetition is allowed, and the rule of it is this: it's n plus r minus 1 factorial over r factorial times n minus 1 factorial. So these are the two types of permutation. The one of them is repetition is not allowed, and the other one repetition is allowed. This may sound complicated, the equations may sound complicated, however they are very, very easy. First of all, you just have to find whether in the combination repetition is allowed or not. After you find out, you just have to find n and r and you plug it into this equation and you'll get how many numbers we can get that particular combination, or how many arrangements we have. So let me give you examples on both. So our first example for where repetition is not allowed is this one, which is how many ways we can get 3 pool balls out of the 16. Here we don't have any repetition. Why? Because basically we have 3 slots, and once we pick one ball, we cannot put it in the second slot at the same time. So how many ways we can get 3 pool balls out of the 16? And why do we have combinations instead of permutations? Well, we have combinations because arrangement of the elements do not matter. If they were matter, we would use the rule where it says n factorial over n minus r factorial. However, instead of that, we use this rule, which is n factorial over r factorial times n minus r factorial. So our n here is 16 and our r here is 3. So basically we get 16 factorial over 3 factorial times 16 minus 3 factorial. And this is 16 factorial over 3 factorial times 13 factorial, which is 560. You can do the math by yourself, but it is 560. So we can get 560 different ways where we get 3 pool balls out of the 16 balls, where arrangement of the elements or of the balls do not matter. So as you can see, we didn't have any repetition. That's why we use this rule, which is n factorial over r factorial times n minus r factorial. So what happens if we have repetition? So we have to, in that case, we have to use this rule, which is n plus r minus 1 factorial over r factorial times n minus 1 factorial. So if we have this example where repetition is allowed, it basically says if we have 5 flavors of ice cream: banana, chocolate, blackberry, strawberry, and mint, and we can have 3 scoops, how many versions or how many variations we can have? Well, basically this is repetition is allowed because you can get 3 scoops of the same ice cream. We can get 3 scoops of blackberry or strawberry, or we can get 3 scoops of different ice creams. Since repetition is allowed, then we use this rule, which is n plus r minus 1 factorial over r factorial times n minus 1 factorial. So our n here is 5 and our r here is 3. So basically what we get is 5 plus 3 minus 1 factorial over 3 factorial times 5 minus 1 factorial. So above we get 5 plus 3, 8, minus 1 is 7 factorial over 3 factorial times 4 factorial, and this is 35. So we can get 35 different ways where we have 5 different flavors and we get 3 scoops. We can get, for example, a scoop for blackberry, strawberry, and mint. We can get a scoop for chocolate, blackberry, and strawberry, or 3 strawberries or 3 mints. So we can get 35 different ways where we get 3 scoops and repetition is allowed. So as you can see, there were a difference between this example and the previous example of the balls, where in the balls repetition were not allowed. That's why we used the rule which said n factorial over r factorial times n minus r factorial. However, here we use the rule which says n plus r minus 1 factorial over r factorial times n minus 1 factorial. Here we have repetition. However, in the previous example, we didn't have repetition. That's why we used the other rule. So basically, the general idea of combination is rearranging of elements regardless of order. The notation is NCR-seq, standing for combination, and n is total number of objects and r are number of objects chosen. So with the rules we had based on repetition or not, the first one, repetition, is not allowed, and it is n factorial over r factorial times n minus r factorial. The second one, repetition, is allowed, is n plus r minus 1 factorial over r factorial times n minus 1 factorial. And this is about combinations. So let's check out another concept in combinatorics.